Hi everybody. All right, we're in geometry. It's Friday. Things are looking up. We're going to look at section 7.3. And now we are taking those similar polygons to another level by proving triangles similar. Okay, so you're used to proving triangles congruent by like side, side, side. Can you name any more of them? Right now you should be naming some more of them. Can you say any of them out loud? How can we name triangles congruent? Was Ben the only one to say something there? We have side, side, side. What else? Side, angle, side. What else? Come on, people. Talk to each other. Okay? Those are all ways to prove triangles congruent. Now we're going to look at ways to prove them similar. So what has to happen for them to be similar? We already saw we need the corresponding angles congruent. And what else do we need? Can you say it out? Whose hand is up? Everyone's? Awesome! Way to go, people! You guys so are amazing. Okay, corresponding angles congruent. What else am I going to say? Corresponding sides are what? Proportional. Okay? So that has to happen for them to be similar. Now what's cool there are some shortcuts. So now we can actually use three ways, three theorems, postulates, to prove triangles are similar. And these are them. AA with the similar symbol. So this is called the AA similarity. So we can use that. And let's draw a picture for what that would look like. That would be if I have a triangle and another triangle that is same shape but different size, right? And I have two sets of corresponding angles that are congruent, so I can say that these two triangles are similar because of that. I don't have to look for all three being congruent. I don't have to look even at the sides. I can say, oh my gosh, I saw this, so I'm done. They're similar. Boom. Okay. Another way is side angle side similarity. So what does that look like? Well, I again have two triangles, same shape, different size. And I'm going to have sides, corresponding sides congruent. No. Okay, that's not going to be true. So I'm going to erase those little lines, which is going to erase my whole triangle. I wanted to make sure you were aware of that, though, so I'm starting over. So I have, they're not going to be congruent because then they'd be congruent triangles, you guys. So the sides, when they're talking about the sides in this case, we're looking at, I'm going to need to label them. We're looking at side AB. So I'm going to write that side AB. Goes with, is proportional to side DE. So we have proportional sides here. Okay? So BC relates with EF. And we are able to form a proportion. They are proportional to each other. And the included angle, so which angle am I going to show here? It's going to be the one that's formed by those two sets of proportional sides. Okay? So there's another way to see that two triangles would be similar. Last way is side, side, side. So again, if I have my two triangles, same shape, different sizes, their sides are not congruent, the corresponding sides are not congruent, they're in proportion with each other. So now my proportional setup is going to be quite long, but I'm going to write it. AB corresponds with DE. Okay. Just as, I need a new color. Let's pick blue. BC corresponds with EF. Just as, and I need the final set, and so I'm not even looking at any angles. I should have picked a new color. AC corresponds with DF. Okay, so every single side, corresponding sides are in proportion to each other. Okay. All right, so The got it problems. Let's start on those. So let's look at got it problem number 1 on page 451. And you are trying that out. Pause the video, please, and try and figure it out. Murphy, try to not multitask too much. We're trying to accomplish more than just the video today. Okay? All right. So starting in, hopefully you pause the video. Part A. Are the two triangles similar? Well, when I look at those two triangles, 39, 90, and then I have 90 and 51, right away my brain goes to angle-angle similarity. But in order to have that, I have to have two sets of angles that are congruent. And right now I have one set, and then the other two don't look the same, so I'm like, oh, maybe they're not. Well, of course, my mathematical brain goes to, well, I wonder what these third angles are. So if I calculate and find those third angles, the third angles turn out to both be, well, I take 180 minus 90, which is 90, and then subtract off that 39, and I'm at 51 degrees right there. If I do the same thing over here, 180 minus the 90 is 90 minus the 51, and I'm at 39 degrees. Did I do something wrong? 180 minus 90 is 90, and then I take the 90 and subtract off the 51, and I'm at 39. No, I did that right. Okay. All right, is there a joyous moment here? Well, these two angles are not corresponding with each other because that's 51 and that's 39, but 51 corresponds with 51, so I do have two sets of corresponding angles that are congruent. So yes, they are similar by AA similarity. In part B, are those two triangles similar? Well, I'm seeing I have two sides that are the exact same size and two sides that are the exact same size. So let's say that's 4 and that's 4 and that's, I don't know, 1 and 1. Would those be in proportion with each other? Yes. And then it gives me, this is 62. These are unknown here, but I can find them. And how would I do it? I would take my 180 minus 62, which is 118, and divide that by 2. And I'm at 59 degrees for both of these. And then this one gave me 68 here. If that's 68, then this has to be 68, which means that the other one would be 180 minus 136, which is 44. So do I have their included angle the same? So I could say side angle, side similarity. No, I don't. These were not the same, the included angle. So I would say no, they are not similar. Okay? All right, going onward to got it problem number 2 on page, what are we on? 453. Again, pause the video, try it out. Got it problem number 2. See what you think. Because I'm starting in, looking at similarity again. Okay, in part A, I have 3 sides given and 3 sides given on the other one. So right away my mind goes to side-side similarity, and I'd have to make sure that that's true. So I'm going to see if the sides are in proportion. So I'm going to go 6 goes with 12, just as 9 goes with, 6 does not go with 12. 6 would go with the 8 because that happens twice, just as the 9 goes with 12. Are these the same? Well, I could simplify both ratios, or I could look at their cross products, the means and the extremes. 9 times 8 is 72, and 12 times 6 is 72. So it works. It's a true proportion. So I'd say yes, they are similar by side, side, side. Part B, a little tougher. You have 2 triangles that are overlapped. So I have one smaller that I drew really badly there. Boom, boom, boom. That's a 6, 8, and 90 degrees. And then my next one is going to be the bigger one in the picture, still 90, with this side is now going to be 12 and this side 16. So right away my mind goes to maybe it's side angle side similarity. In order to be that, I do have the included angle that's congruent. Are my sides in proportion with each other? Yes. So 6 goes with 12 just as 8 goes with 16. They're both a half. So we're good to go. And yes, they are similar. The final got it problem that's proving triangles congruent. Page 453, number 3. And in part A, you're doing a proof. And it's going to be those 2-column proofs. Okay? And in part B, you are, low on battery, people. You're just answering a question. Okay? So pause the video, try it out, help each other, see if you can figure this out. And I will start when I have charged my iPad. Thank you.